Okay, so now we go to pipe rack structure, we proceed. So go to new and standard millimeter IPT like the way we started the other one. First draw the sketch. It is upright, so I want just to draw it that way. I'll draw a rectangle. When you draw in Inventor, don't waste time like you draw in AutoCAD. Be quick here. Trim. No time wasting. Horizontal constraint. Make sure this is constrained horizontally. Vertical constraint. Check the lines are properly constrained. Okay, fine. Horizontal. Make sure these bottom points they are constrained and they must be registered to the that point. And dimension from there to there. I don't want to start with that one. We start from the top to there is 6 meters, 6,000. And from there to there, I just love to measure from the center point because even if I delete something, it doesn't affect anything. 4,000. Then from there to there, 2,000. Then of course the spacing is gonna be 10 meters to match the plant layout. Okay, and I need to do vertical constraint. The center point of the line to this point. Then it's fully constrained. Try to be neat. These lines must be just, the dimensions must be smart. Is this 6 meters? Yes. Okay, fine. After finishing, you finish, then save it as skeleton, pipe rack, I'll call it 2. Because we've got another one too. Okay? You must create the folders for your project so that everything goes smart. Okay, after this, I'm going to open new. Then I go to standard millimeter IAM, create. Then I'll bring the skeleton. Okay, it appears this way. I don't like just to let it be like this. I need to constrain. I'll go to the origin of the page and the origin of the item. Then constrain. I want it to sit upright, so I'll follow this one. The one that is following its size, and this vertical one. I'll say apply. Again, I'll go to the next constraint, this one, and I want the one that is crossing this one, yeah, there. Then you can see it's sitting upright, no? It makes the work beautiful and interesting. Hey, apply. So this is fully constrained, okay? Now I want to go and choose the material. Save it. It wants you to save. So this is pipe rack structure. I'll call it 2. Save. Yes. Okay. So after that, we need to bring the material. Let me try to check if we have got what we can use from the steel tables. And we need the columns. H section. We need the H section, H section, H section. The parallel one. Okay, so we are going to work with the 254 by 254 by 73. The big one, because it's a big structure. Do we have from the designs here? Let's check. JIS will not give us. Let us use British Standard, BSI.
What's JIS? Is that Japanese?
Yes, just some other countries. Okay. Okay, so we are choosing the material. We need H section. Do we have H section on JS? We have got roti, universal beam. Yes, we've got. Great. We are now in British Standard. I guess this is where we'll find on. No, it's the I sections. H section must be there.
Check the Chinese.
Universal column, sorry. I took beam. So these tables are made based on British Standard, ne? So we are using this one. Perfect. Oh, I love it. You click there and you click there. So I work with the standard. Yes, beautiful. Okay, so I've got there. If I want to rotate these ones, I just need to go and change the angle here. You can change the angle. You can stretch this. Don't be limited. You can change the angle there 90. Then they'll sit that arrangement. But we want 0 because we love it this way. It's so beautiful. Then after you do that, now we choose. There are 2 ways. Do we need this one to come with the beams? Or we need the beams? Oh, the other way. That one is beautiful. Let me save this one the way it is. We bring the beams on this one. Okay. So this is one way you can do. You can also add the I sections. I'll just follow what I've explained already. But you can create the top on its own. Where is the universal beam? There. And I'll choose which one? 254 by 146 by 31. That's the one. You click that one, you click that one, you click that one. Look how beautiful it is. Oh, so beautiful. You click. Then you can see the ends there. They are interfering with each other. In real life, that doesn't happen. How can the solid material interfere? So we don't want that. So what do? Let us see. Fix the corners. We select this member and we select this one. You can see how it works. 10 millimeters, that's the space between the two. Okay. Now it is normalized. If you check, you can see how it sits. And if this is beautiful, even this one now we can do the corners, just like that, and the 10 is there. So wonderful. You come to this one. Now the previous we were using corner joint. Now we go to trim and extend. You click this face, we trim this one. 10 millimeters, still kept the same. I can also go to trim. I'll click this face and this one and that. Okay, then I'll turn the other way. Okay, so we trim, click this face and that one. I can do multiple trimming, 10. Even if there are so many components, I'll just enjoy it that way. So this is what it is. Okay, so this is not done. We need to put the end plate and we also need to put what? The base plate and drill the holes. I want my work to be finished because I love it. Okay? So after that, I need to go to new. I want to create a base plate. Go to standard millimeter IPT. Create the base plate. Okay, vertical constraint. Okay, horizontal, like that. Then I love it when we make it equal like this, so that when I put one measurement, it's perfectly done, because this is for the base plate. So it's 350, done. Finish sketch, extrude. I have a base plate, 16 millimeters thick plate. Then I need to drill the holes on the corners. There, I'll click that edge and I'll say 25, because we want it that way, and 25 again. Then the diameter, we go leave it 20, we are using M20. Then finish, go to pattern and click. You should know your software very well, because if you don't know it, you'll be looking for what to do. So we are going to have 300 spacing, and this direction also 300 spacing, 300, and we flip the direction. So we are going to have those holes done. After that, we save it as base plate. So we have got 350 by 350 base plate. I can say 82. Yeah, because I'm just redrawing it. And give it a color, so that at least, let's give it a good color, maybe the same color, red. Fine. Then after that, go to your assembly, the one that you did for the pipe rack, and bring this very guy you have just done now. It's this one. Click and click, constrain. This face must be matching with that. Apply. Then now you can see that you can't flash the ends. You can't. It means you are doing it the wrong way. So what do? Look for the center, for the planes of this one, which we have. Is this the one? No. We need this one. We go to the planes of this one on origin. Then this one, we look for it. Which one is this one? You point. You see, by pointing at this one, it tells you which one. Go to its origin and their planes. Work with planes. I love it when I work with planes, because my work is true. You go there, select that plane, and go there, select this plane. Beautiful. Apply. Go there, select that plane, come here, select this plane. Once you hear the word in tone, then you know they are working well. Choose the, okay, we are done, because we used the bottom surface constraint. Just like here, if you didn't understand well, let's minimize here, and we minimize that one, so that we try to redo this one. Expand it, expand the origin. Let us constrain first this face. We constrain with that face. Yeah, apply. Let us look for this member. So you go to all of it, go to this, expand it, and check which one is that. Is it this one? Yes. Expand, go to its origin, and drag them down. Constrain, zoom it so that you can see what you are doing. This plane, constrain with that one. Oh, this is so nice. That one and that one. If you don't hear the word in tow, try to change to see. Okay, fine. Is this moving? No. So this is fully constrained. I want the end plate. I've already left 10 millimeters there. I'll make the end plate now, so that everything is there. I can even color the whole drawing the same color. So select, no, just go to all of it. The entire thing, you just go to select everything, or select this, that, and the appearance. No, I don't want to choose from there. I want to choose from this side. That one. No, select that, and appearance, that one. Yeah, we are using the chrome color. Okay, so then save it, because your electricity, you know, at times it just goes like that. Now we go the end plate. Go to new, standard millimeter IPT again. We need the end plate, draw a sketch, vertical constraint, that one, and that, horizontal, this one, and that. Then need dimension. What is the dimension we are going to use here? I don't want you to guess. Go to your member and inspect. You must learn how to use inspect. Click there and inspect this length. It's what? 146.1. Inspect from there, inspect to up to there. It's 251.4. Go and make the plate exactly the same. Okay? So we go to the sketch we are busy with. The last one, 146.1. Then this one, 251.1. Okay, let me check. I thought they listened, they didn't. From there to there, 0.4. Okay, this is 251.4. This is according to structural steel detailing. Use the actual measurements. Then after that, are you dodging?
Me? No, sir. I need to go handle some stuff. I need to go to the police station as well. I told Tube just now. I don't want to disturb you while you're busy.
Okay.
I'm not dodging.
Okay, no problem. I can see.
Guys, see you tomorrow morning, sir.
Okay, sharp. Where is that red? Okay. Okay. Sharp. So this one is the 251 point. Okay, let us write just to round it off. 251 by 141 by 10 millimeters thick. Then I'll call it what? End plate. Save. After that, constrain it. Oh, bring it first. So the end plate, this one, when we drill the holes later, they will appear. 1, 2, 3, 4, 5, 6. I could use array, but I just want to do it repeatedly so that the understanding is there. So you click this face and you click the face of this the eye section, that face. Mate, apply. Because the sizes are the same, I'll just use flash. Apply. Flash. Apply. So I've got a plate there. If I check, now there is no gap here. It shows there is this plate and this one.
So you don't explain the plate.
Now because I'm explaining, so I have to give you everything you want. Then you can do it yourself. Constrain that one to that one. Mate, apply. Then this flash, this one to that one. Apply. This one to that one. Apply. Okay. Anyway, because of the time, at least two you have seen how I've done them. These ones I can just delete and use array. How many plates do I have? 1, 2, 1. Where is this one? Then 1, 2. Okay, fine. Then I can use array. This one and this one, pattern, then that direction, swing it around. Then the measurements is 2000 and I need how many? 3. Then okay, they are there, the plates. Okay, so I'm done with this one. If there's any question, feel free to send me a message, WhatsApp, so that I can explain this one. So this is the structure that is going to be used for the pipe rack. So save it, it's fully done, and let's proceed to the next one.